So I apologize for having to be gone today, but duty calls as a parent again, and my son is still sick. So we're going to have to go ahead and do this lesson as a video lesson. Now I think this is one that's going to go a little more smoothly than some of our past video lessons. I think you're going to be able to follow this one without too much difficulty. So we're going to continue to build on what we did yesterday with our solving, where we were solving with fractional exponents and we were using fractional exponents to solve. So today we're going to solve equations with fractional exponents already in them, and we're going to solve equations with radicals. So we're just going to have this one lesson, and when you finish up working on this, I want to give you some time to work on your review packet, so please use that time wisely. So let's go ahead and look at solving an equation such as this. 2x to the 3/2 power equals 250. To begin this process here, I need to get that x by itself, just like I always have in traditional solving. X to the 3/2 equals 125. Now, our new step here is this idea that we need to get rid of that 3/2 power. I need that to go away. And I want to get x, or x to the first power is always my goal. We don't write the first power, but that's always my goal. So in order to make this into x, I need to take both sides to the 2/3 power. So I'm always going to raise my original problem to a power that is the reciprocal of the original exponent. So therefore I had 3/2. To get rid of 3/2, I take it to the 2/3 power. And the reason why that is, if I do my power rule, my power to power, I multiply 3/2 times 2/3 and I get 6/6, which is 1. So I get that x to the first power, that x by itself. And whatever I do to one side, I must do to the other. So if I take the left side to the 2/3 power, I must also take the right side to the 2/3 power. So to get to my solution, I use my rules from yesterday. This is the cubed root of 125 squared. If I plug that into my calculator, I'm going to get an answer of 25. So in this case, x is 25. Alright, we're going to go ahead and move on to an example with a radical in an equation. Now, if you think we're moving too fast here, make sure you use that pause button or rewind and go back and look at the previous problem. If you didn't quite follow that, check the steps or maybe ask someone around you. We're going to continue on here though and look at solving a radical equation. The next couple examples are going to go pretty quick because we're just going to think back to what we did when we first learned the square root method for solving quadratics. And we said if I want to get rid of x squared, I take the square root because a square and a square root are opposites, so they'll cancel each other out. The square and the square root cancel each other out, leaving me with just x. Well, we're going to use that exact same process, that exact same thoughts, to get rid of the square root. We're just going to go the other way because we solve equations by using inverse operations. The opposite of a square root is a square. So if I want a square root to go away, I square both sides of the equation. The square root and the square cancel each other out, leaving me with this nice, easy, simple equation. I add 5. I divide by 3, and I get x equals 7. Now, it's really important when you're working with radical equations that we check our answers, and you're going to see why this becomes an issue later, but you will always need to check your answers. And so I'm going to plug 7 into the left side of my equation. 3 times 7 is 21, minus 5 is 16, and the square root of 16 is 4. So I did get my equation equal to 4, like I was supposed to. So this equation does work. We're going to come across some later that might have an issue with our solution. Our next example is a simple form of just a different form of our solving using squares to get rid of square roots. Now you notice here I don't have the square root by itself. I have radical 2x minus 7 equals negative 4. In order to square, I must first get my radical by itself. So I have radical 2x equals 3. Now when I have a radical by itself, I can square both sides, giving me 2x equals 9, so x is 9 halves. And again, I always check my solution, so I'm going to plug in the radical 2 times 9 halves minus 7. Well, 2 times 9 halves is 9. Square root of 9 minus 7 is 3 minus 7, which is negative 4, which is what I was supposed to get. So that did work. And again, you'll see why that's important in a moment. This example looks a little bit more intimidating. When you look at this, this seems like it's going to be more complex. And you definitely will make this complex if you just say, I want to square this right away to get rid of both those radicals. Because if I did that, I end up with a situation where I have to multiply a binomial times a binomial, or do what we call foiling. And I don't want to do that. That's going to be too much work, and it's actually not going to gain me anything. So I'm going to go about this in a little bit different way. If you have two radicals in the same equation, in order to solve them, I always want to begin by getting a radical on each side. So I'm going to move this second radical over to the right side of my equation. Now, when I have a radical on both sides and they're not tied together with that plus or minus issue, now I can go ahead and square both sides. The square root cancels out and I get 3x plus 2. When I square the right side, I have to square both 2 and radical x. 2 squared is 4, radical x is x. And again, once I get rid of the radicals, I'm going to be left with equations we've worked with many times before. I have 3x plus 2 equals 4x. I need to minus 3x over to the other side, giving me 2 equals x. And so again, I just need to quickly check and make sure my answer works. I have radical 3x plus 2. So I'm going to plug into that radical 3 times 2 plus 2 minus 2 radical 2. And I want to know if that equals 0. 3 times 2 plus 2 is 8. So I get radical 8 minus 2 radical 2. Radical 8 is 4 and 2, 2 and 2. So I end up with 2 radical 2 minus 2 radical 2, which is 0. So that did work. All right, we have one final example to look at. Our final example here is going to be one like this, where I do have a binomial equal to a square. Now in this case, there's no way around it, no way to get out of it. I'm going to be stuck doing foiling. I'm going to be stuck multiplying this out, or I'm going to square both sides to get rid of the radical. I'm not wanting to work with the radical, so I get rid of that right away. So on the right side, I'm going to have 2x. On the left side, I have to multiply my x minus 4 times x minus 4. So we're just going to do this on the side, and I FOIL that out, and I end up with x times x is x squared minus 4x minus 4x plus 16. So I'm left with, on this side, x squared minus 8x plus 16. And yes, you are going to be expected to be able to solve quadratics. It's a good practice for you coming into your final exam anyways, because you're going to see quadratic equations on your final exam. Now, in order to solve this, I always want to set my quadratics equal to 0. So I minus 2x from both sides, making it x squared minus 10x plus 16 equals 0. I always want to check and see if my equation's factorable, because that's going to save me time. And in this case it is. There are numbers that multiply to 16 and add to negative 10. And those are x minus 2 and x minus 8 are my factors. So my two solutions I get are x equals 2 or x equals 8. Now, I'm going to go back and check my solutions because, like I said, it's important when we're doing this that we always check our solutions. So I go back to my original equation, and I have 2 minus 4 equals the square root of 2 times 2. Now, 2 minus 4 is negative 2. 2 times 2 is 4, so I get negative 2 equals 2. This is a problem. This actually does not work. Negative 2 does not equal 2. So therefore, this is not a solution. We call that an extraneous solution or a fake solution. It works algebraically, but when you go back and check your answer, it doesn't work. And the reason why it doesn't work comes back to our whole solving a quadratic and getting the plus or minus answers. That whole issue with the square root method, well, the plus or minus doesn't apply going the other way. And so it ends up causing a unique situation where we end up with these solutions that work out algebraically when we calculate them, but they are actually not correct solutions. They don't plug in and work. So if I look at my second solution here, my 8, I'm going to do this in the bottom right corner here. If I plug that in, 8 minus 4 equals the square root of 2 times 8. 8 minus 4 is 4. The square root of 16 is 4. So that is true. This is a real solution. So you always need to plug your answers back in and check them because it is possible when solving square root equations to end up with what's called an extraneous solution. A solution that works when you calculate out your work, but when you plug it back in, it's actually not an accurate solution. So you're always going to have to check your answers to make sure they're not extraneous. All right, your homework's going to be out of the book. Good luck, and we will see you on Monday. Enjoy your weekend.